Stephen Hawking was a brilliant physicist who devoted his life to uncovering the mysteries of the universe. He was known for his groundbreaking contributions to the fields of cosmology and quantum gravity, as well as for his popular science books that made complex concepts accessible to the general public. Hawking uncovered that black hole physics had more ambiguity than even quantum mechanics. However, this level of uncertainty seemed unacceptable as it led to many of the fundamental principles of physics breaking down, depriving us of the ability to forecast anything about a black hole's future. In one of his final works, Hawking put forth what he called his final theorem, which proposed a solution to one of the biggest puzzles in physics, the black hole information paradox. The black hole information paradox is a long-standing problem in physics that arises from the fact that black holes seem to violate the laws of quantum mechanics. According to quantum mechanics, information cannot be destroyed, only transformed. However, when matter falls into a black hole, it appears to disappear from the universe entirely, taking its information with it. This creates a paradox. If information cannot be destroyed, then what happens to it when it enters a black hole? Hawking's final theorem proposed a solution to this paradox, suggesting that information is not actually destroyed when it falls into a black hole. Instead, it is stored in a sort of hologram on the black hole's event horizon, the boundary beyond which nothing can escape. This hologram contains a two-dimensional representation of all the information that has ever fallen into the black hole, encoded in the fluctuations of the event horizon. The idea of a holographic universe is not a new one. It has been proposed by other physicists as a way of reconciling quantum mechanics and general relativity, the two pillars of modern physics that are notoriously difficult to unify. However, Hawking's final theorem took this idea a step further by applying it specifically to black holes and the information paradox. Hawking's final theorem was published posthumously in 2018, 2 years after his death. The paper was co-authored with Malcolm Perry and Andrew Strominger, two of Hawking's colleagues at the University of Cambridge. While the theorem has not yet been fully tested or proven, it represents a significant step forward in our understanding of the nature of black holes and the universe as a whole. Besides, Thomas Hertog was a collaborator of Stephen Hawking and worked closely with him on his final theorem. After Hawking's death, Hertog continued to develop and refine the theory, and he has provided more detail on the radical solution they came up with. The solution proposed by Hawking and Hertog involves the use of a new concept called soft hair, which refers to tiny quantum fluctuations that are present on the event horizon of a black hole. According to their theory, these fluctuations contain information about all the matter that has fallen into the black hole, and they are preserved on the event horizon rather than being destroyed. Hertog explained that the holographic principle, which suggests that the universe can be represented as a two-dimensional image on a surface rather than a three-dimensional space, is central to their theory. They propose that the soft hair on the event horizon contains a holographic record of all the matter that has entered the black hole, allowing the information to be preserved. Hertog also explained that their theory has important implications for the concept of causality in the universe. According to their theory, the existence of soft hair on the event horizon of a black hole means that information can escape from it in a way that does not violate the laws of physics. This challenges the traditional view that information that enters a black hole is lost forever, and it has important implications for our understanding of the fundamental laws of the universe. While their theory is still in the early stages of development and has not yet been fully tested, it represents a radical new approach to understanding the nature of black holes and the universe as a whole. As Hertog said in an interview with The Guardian, it's a step further in our quest to understand how the universe works. In conclusion, Stephen Hawking's final theorem is a testament to his genius and his lifelong dedication to unlocking the secrets of the universe. The concept of the multiverse proposes that our universe is only a singular component of a vast collection of other universes created by the Big Bang. A paper, which was written during the author's final days, delves into the notion that we could potentially identify and measure other universes utilizing a detector that could be installed on a spaceship. His proposal of a holographic solution to the black hole information paradox has the potential to revolutionize our understanding of black holes and quantum gravity, and to bring us closer to a unified theory of everything. According to Hertog, The theory of inflation, which proposes that the universe expanded rapidly before transitioning to a slower expansion, was untestable. He states that he and Hawking had aimed to transform the concept of a multiverse into a scientific framework that could be tested. While Hawking may be gone, his legacy lives on in the form of his groundbreaking contributions to physics and his unwavering curiosity about the mysteries of the cosmos.